Okay, second video for day 3. We are going to go back to a definition we learned in week 1, which is called complementary angles. These are angles whose sum is 90 degrees. For example, 60 and 30 equals 90. 10 and 80, 20, 70, etc. These angles are called complementary angles. Now, why is it important? Is because when you have a right triangle, since one angle is 90, the other two angles are always complementary. 1 plus 2 plus 90 equals 180. So angle 1 plus angle 2 is always 90. So in a right triangle, we have this very nice situation where the two angles that are not right are always complementary. And since we have this nice thing happening in a right triangle, and we have been studying right triangles for trig ratios, it makes sense to see if there is a pattern. Okay, so to do that, I have this triangle here with two reference angles, 1 and 2, and all 6 ratios. So I would encourage you to fill this out before you watch the video and see if you can find a pattern. Okay, let's start with sine of angle 1. For 1, the opposite is y, so this is y over r. Cosine of 1, adjacent is x, so x over r. Tangent, opposite is y over x. Now cosecant is the reciprocal of sine, so it's r over y. Secant is reciprocal of cosine, so it's r over x. Cotangent is reciprocal of tangent, so it's x over y. Now let's look at the angle 2. From 2, the opposite is x, right? So x over r. Adjacent is y, y over r. Opposite is x, so it's x over y. Then cosecant is the reciprocal of sine, so it's r over x. Secant is r over y, and cotangent is y over x. Once you have this table, now let's see if there are some obvious relationships. Notice sine 1 equals cosine 2, and cosine 1 equals sine 2. Tangent 1 equals cotangent 2, and cotangent 1 equals tangent 2. Cosecant 1 equals secant 2, and secant 1 equals cosecant 2. Now, what are we going to do with this observation? What are the things that we talked about? Complementary angles and trig ratios. So this gives us that since 1 and 2 are complementary, there is a relationship between the trig ratios of complementary angles. Here is the conclusion. Trig function of an angle is equal to the trig cofunction of the complement of the angle. Meaning, sine of theta is cosine of 90 minus theta. Tan theta is cotangent of 90 minus theta. Secant theta is cosecant of 90 minus theta. Similarly, cosine would be sine of 90 minus theta. Cotangent theta is tangent of 90 minus theta. Cosecant theta is secant of 90 minus theta. So there's a very nice symmetric relationship between these, not only between the trig ratios, but also the trig ratios of the complementary angles, which is very nice because the two angles of a right triangle are always complementary. So this is a very useful result. This is all for video 2.